put the kid down. I have some time before bed. I'm going to get back to this, and we'll see how far we get. We'll just see. We're just gonna see how far we get. I also have a present to the regulars in the chat if anybody happens to show up. And if not, sorry, you'll just have to find out in the morning, or whatever it is in your local time zone. But yeah, I got us a little present that I think you'll be happy with. It's from me to me, but I think you'll generally appreciate it. Anyway, I'm going to wait a little bit for that because I'll wait to see if anybody pops on. In the meantime, yeah, so earlier today, we did some code. We surely did. I guess I can just start here, as always, turning things on, demoing what we have so far. So I was refactoring all of the code and adding actual proper error checking and bailing and retrying. And it looks like it is immediately failing to initialize the drive. So there's almost certainly something, that I'm screwing up. So let's dive into that. As you can see, I actually am printing some messages about failure or not failure, which will hopefully maybe be helpful, but who is to say? Who is to say? Anyway, let's dig in. It is failing at initialization, which is interesting because it is when it's sending the recalibrate command, which is odd because all that does is seek the head back to where it needs to go. So my guess is I'm probably, again, screwing up clobbering registers, doing crap like that. I'm trying to decide. I think I might pop this into FCEUX because I may not, actually have the hardware here, but I should be able to pause it at a breakpoint and inject the values that I need into the registers that need it to simulate what the drive would be doing, just to make sure there's not any obvious, bugs. If it's because it could just be that I am failing too quickly, which would be weird but possible. So this is already built. I guess let's find. I guess we need to find a place where we jump to the recalibrate loop, FDC recalibrate. And the first thing we do is jump to FDC select drive, and then we load 10. Well, we load 16 into X is what we do. So we're looking for a JSR and then load X hex 10 and then decrease X. Let us fire up FCEUX and see if we can find that line, put a breakpoint there, and make sure our code isn't totally stupid when it gets there. I might have to put a few more breakpoints before that as well, just because the send FDC command method is not going to... Oh, well, you know what we can do is we can, because that gets called everywhere, send FDC command and read FDC data. I can, for the moment, fudge those a little bit, just so that they always work and I can make sure it's not them failing for some reason, I'll just, because if I don't see the same errors when mocking those in, then those aren't the problem. So anyway, let us look to where those are implemented. Send FDC command. I think what I will do... Hey, Taco Man! Good to see you here. I don't know who else will join, but it's cool that you made it, because, I don't think anybody was expecting 2 streams in a day. I wasn't. And it's nighttime, so apologies in advance for talking fairly quiet, because the baby is right there. And he is snoozing, so. Being a good citizen of my household, or at least trying. Anywho, so let me start by just mocking the send FDC command and, what's the other one? the read FDC data. So the annoying thing is that, I mean, I can just make these return early and put, you know, sentinel value, not sentinel values, but, you know, just like have it return a success code and always return 0. And I'm just gonna have to be aware of that as I'm doing it in FCEUX. Hey, Wereworm is here. Cool. Taco Man says, I always try and get in the stream whenever I see it. Much appreciated. I enjoy having you guys here, so. Anyway, yeah, so with that caveat and double checking the code to make sure I don't, well, I'll just step through it, yeah. Anyhow, so temporarily, let's write temporary mock, there we go, and temporary mock, and then literally just, let's see, on read FDC data, we put the value in A and the status in X, right? So I'll just return 0 for both. Load A, 0, load X, 0, and it's fully possible that it's these exact functions that are like clobbering registers and whatnot, but again, mocking them will help to tell me if that's the case or not, I suppose. And then RTS. And then I'm just going to do the same thing with get FDC, or send FDC command, temporary mock. And for this one, all we do is return the status in A, and that is it. So that should be my whole mock there. And now I guess we really need to set a breakpoint at when we start entering into floppy disk related things, because those commands are always going to send back junk, so I need to make sure that I, you know, edit my registers to have something believable in them. And so what will we be looking at? That will be right after FDC wait loop, and I think story 6000 load X 20 is going to be fairly obvious. So let's build this, pull up FCEUX, and as I mentioned before, but it was before anybody was frickin' on here, and because it's largely for Wereworm, I have a present coming up. Don't get too excited. It's a present from me to me, but I think you will be pleased. Though the funny thing is that at this point I don't know if it's that useful, but if you want to take guesses in the chat, go for it. All right, open this. Go to the debugger. Pause the NES. Reset the NES. And let's look for some code that looks believable. What was I looking for? It was story 6000 load 20, I think. Okay, there's our PPU initialization crap. More PPU initialization crap. Getting close. There it is. Story 6000 20. Here we go. So where is the actual start of attempt read sector? That occurs at the first pull A here after this. So we load A2, we push it onto the stack, and then we immediately pull it off at the top of this loop. So breakpoint E195. No. I mean, it's cool that apparently I can debug name symbols, but I don't need that right now. E195 on execute. Very good. So there's that breakpoint. And then, like I said, I want to set another one just so I don't miss it in my stepping over things. The one that is taking a shit is FDC recalibrate. And again, I just want to kind of step through this and see if I edit the registers to have believable values, if there's still just like code issues in here that cause it to take a crap or exit early, even if the floppy was sending back perfect data. So recalibrate. So that starts with a JSR, then loadx10, JSR, loadx10, JSR, loadx10. That is interesting. Lots of. That looks like our code for. Oh, this is the setup stuff for read sector. Yeah. Because it's calling the get in send command stuff and then checking to see if it succeeded, and then if it didn't, bailing out. Yeah, cool. Anywho, so we should be close, I think. Actually, we may have shot past it. Load AOF. No, that is a hex 10. Ooh, is this it? Load X10, and then immediately DX and BEQ. This looks like it. Cool. Yes. And the JSR up here should point here. So this JSR E223, E223, beautiful. So let's add a breakpoint at E223. On execute. Okay. And yeah, damn it. You called it, Wereworm. I figured I probably gave that away, but ta-da! I figured it could be useful anyway. Also, I mean, not that I was expecting it to be like super expensive, but they are cheap as hell. No one told me how freaking cheap these things are. I mean, it's like, you know, working person cheap. $30. $30. $30 for this thing. I mean, maybe like 35 on Amazon. Like 2-day shipping. I know I keep buying things on Amazon and then I keep bitching about it. What do you want from me? Anyway, never used one before, so that's interesting, but it should be a good sanity check. Yeah. So that's a thing. And I will probably play with that much more in the future. And Wereworm said, always useful for old computers. Yeah, it's kind of bizarre that I haven't had a GoTech at this point. I've kind of just, like, purposefully avoided getting any kind of, like, drive simulator for anything. Just as, like, I only like spinning Rust. I'm hardcore kind of thing. I don't know. There's a vague thing in there. And that's just the way I am. Because of the wonderful whiz I was. So anyway, that'll be fun. I don't know if we'll actually use it tonight, but it'll be... This is the whole point, and I didn't quite see the wisdom of it as fully as I should have at the time it was suggested several times, but of course it will basically remove the specter of any hardware issues, at least on the floppy drive side, which are plentiful on a actual physical floppy drive. Which is why we have all of this retry logic that we're now debugging. Anyway, we're stopped here. We are stopped here, and maybe I should side-by-side this with the actual code. Probably a good idea. This is always annoying, because usually I would Control-B to collapse that file listing window. Oh no, there we go. Right, that's a thing you can do. But my key bindings are such that I cannot do that. Okay, so we are, where were we stopped? We were stopped at the pull A at the top of our read sector loop. So I think I will just, let's see. Well, I'll have to re-remember how the code works because I have to do that every time. But generally, oh no, please tell me you don't do this every time. No. No, no, no. Oh, that's awful. That's just awful. Okay. Uh-huh. Said check the head alignment before using it. Will do. Will do. Well, that sucks. I'm just going to be straight up about it. The fact that this window really wants to resize itself. Okay, apparently only when you have it in snap mode. Weird. Anyway, we have pulled X off the stack, put it back in X, decreased it, and it is not 0. So we should not be taking this branch. And then we throw it back on the stack. So we put X back in A, throw A on the stack, doodly doot, there it goes. And now we print our first string, which of course I'm going to step over all of that string writing crap. So there's the load A, there's the store A, there's the load A, there's the store A for the strings pointer. And then we jump into the print string routine, and I am just ignoring the whole thing. It looks like after that, my stack is not screwed up. All of my registers look fine. Super cool. Then after that, we jump into FDC init, which is immediately where things fail. So yeah, this is going to be where things get interesting. So let's slide down to FDC init right about here. And let's see. So we're just writing to a location that doesn't exist, so this should be just fine. This would be for resetting the FDC in software, but there's nothing there, so it will just silently not do anything. The wait FDC IRQ, though, we are going to have to simulate. So step over, step over, step over, step over, and then I will step into this call to wait FDC IRQ. I probably should have mocked this as well. It now occurs to me. Well, if it becomes annoying enough, I certainly can do that. But anyway, we're going to load a whatever is in 6800, which is the status register, which includes the interrupt bit, and then it's going to be ANDed with 80, but first I believe, be able to edit the contents of A. Yes, I can. That's exactly what I want to do. And as such, they are in fact equal. They should be equal. Let's see. No, it's an AND, so this is a on 0. So it will not take that. And it will return, because it says, I got an IRQ, because I gave it a lobotomy. Alright, so we are back here. We are sending the 4 sense interrupt commands, which, again, we're just going to simulate all of those because I'm just seeing if the code itself does anything untoward, even if the hardware was working perfectly correctly. So we load X with a count of 4, and then we JSR into FDC sense interrupt, which, let me just step into that and make sure it's gonna, yeah, I might want to do, for debugging purposes, I might want to lobotomize wait FDC IRQ really quick, because I'm going to have to keep doing this a lot. FDC sense interrupt. Well, let's look at it really quick, because it might just send data and be done with it. No, it sends data and retrieves 2 bytes back. But that actually should be pretty much fine, because I don't think it waits for anything otherwise. So our lobotomized mocked read data functions should just kind of let that work fine. In fact, I'm so confident about that, I'm just going to step over this. I feel good about it. And an interesting state on the stack. Wish I had been looking at that a bit more, but this already looks like maybe a problem. Wish I could rewind time. Whoops. All right, anyway, let's find back where we were. So here's the DEX, and then we branch again, and we're just gonna keep branching. Let's see. Step over, step over, step into, step over, step over, step into, step over, and let's see. Ooh, yeah, that's that could be doing some shit, because X is currently FF. So we're definitely getting shit screwed up really quick. All right, well that gives me a lead, even though I'm sure that there are a bunch of bugs in here. But clearly, due to the stack getting all fucky, and of course I bet inside of here X is getting all kinds of screwed up. Should I just do my classic save X on the stack deal? Let's go to FDC sense interrupt. And let's just look at all the places where X could get screwed up. Because I don't even think it's the stack. I think it's just X is getting screwed up and I'm trampling over the value of this counter here. So FDC sense interrupt. So the interesting thing, of course, is these are lobotomized. They shouldn't be really affecting X at all in any significant way. Interesting, actually. Send FDC. Oh, wait, no. No, it is, because that's why it's FF, because I am decreasing it from 0. That is why. That is definitely why. All right, so then let's actually go back and preserve X on the color side, just because that's what I feel in my heart of hearts. And that is somewhere over here, way back here. Yeah, let's do our good old friend load A, push A, pull A, transfer A into X, decrease X, and this shit when you don't do it in the right order. And of course, doing this kind of crap is going to make the code a lot slower, which doesn't matter right here, but will matter for some things. Anyway, so you see my conundrum is I want to keep my stack balanced if I'm going to do this. However, this blows. However, I am, at this point, I will be wanting to branch next here, and that will be wanting to use the result from DEX, but I still want to save the value that is in X and push it back onto the stack. I guess if I do it at the top of the loop, I guess. So, yeah, let's do this. Load X04, and then at the top of this, let us transfer X into A, push A, and then, yeah, I think that should keep it balanced. Because when we come back around here, we have decreased X, and then here it shoves it back with its saved value back onto the stack. And if we break out of here, then we don't push anything back onto the stack, so that is fine and stays balanced. So, all right, let's see if we can get to this point. Because that's all fucky. And of course, I still have this inkling feeling that the stack is all messed up here. But let's just see what happens. Same breakpoints, I guess, and then we'll just reset the whole thing. Set it to run, reset the thing, reset breakpoint, here we go. And now we are back all the way up at attempt read sector, at our pull A, and I guess I want to step all the frickin' way down to... Oh, you know what? If I'm going to restart this thing, let's lobotomize the old... whatchamacallit, the wait IRQ bit, wait FDC IRQ. Here we go. Lobotomize it, bro. Temporary lobotomization. End temporary lobotomization. And this will literally just return. There is nothing else it needs to do. I guess just to make sure this isn't causing any issues, or to see if it is causing issues at all, let's at least mess up the A register, because that would happen in this function, and then just return. And then rebuild it, reload it. So I'm going to, shit. Let me, okay, the good thing is that shouldn't change any of my offsets because wait FDC IRQ is all the way at the end of a lot of the stuff. So let me write down my breakpoints, E195 and E223, and just totally kill this because it gets weird when you try and reload stuff in the middle of debugging. FCUX, open, open. That's actually rather interesting. Huh. Huh. I'm sure that wasn't my only bug, but it's fascinating that it gets that much further, especially when there's no floppy hardware on here. But I suppose it's always succeeding at reading and writing floppy drive information and always getting zeros and always succeeding in waiting for the IRQ, so probably shouldn't be too surprising. So, oh yeah, that's probably the main thing that was making it hang in the first place, was waiting for the IRQ, because that is waiting for a bit to go high in a memory location that doesn't exist. So that would maybe tend to make sense. Anyway, let's open the old debugger. A. Oh, look, it even remembers my breakpoints. Beautiful. All right, so let us step over, step over, step over, step over until we get to Udly Doot, where we were failing before, or where things were getting weird before. So let me, I don't even remember what the second breakpoint was. Was it the recalibrate loop or was it the reset? I don't think it was at the beginning of reset. Yeah, let's look for this code and break there. And I think if I just let it go, we should get there fine. Oh, well, definitely. Sorry, this is the FDC init code. It's just going to go there. There's nothing really ahead of this. And in fact, actually, in that case, let's not set our breakpoint here. Let's set it here at this load A13, because if everything is the issue was this would have never exited because of the way that X was getting screwed up. But we're clearly getting through it now. But all we know is that it's getting through it and not hanging, which doesn't indicate to us necessarily that things are, working properly. So let's look for, I guess, really this loop, and then we'll, because this is probably the most notable code. And then I can go from there, and that is load A00, and then 6802 store. Oh boy, this is not a lot of fun with it kind of squeezed over like this. Oh goodness. And also, it automatically repositions the window when you start scrolling. Excellent. Just excellent. Okay, let's find our FDC init. I can also probably generate a symbol map, and might be generating a symbol map without realizing it, but actually that might be useful. Nice screen resolution, bro. Yes, it is. And because I believe in, oh, it might just give me the memory layout. That is possibly what it does. Basic.bin, basic.o. And I thought, let me look at that link.ps1. Yeah, I think there might be a directive for dumping, and I thought maybe I was using it, but apparently I'm not using it. So if I don't have a symbol table file, then NBD. Let's just continue looking for stories 26802. Okay, so this is the top of our code. Also very slow at scrolling. Rather annoying. Oh, this is it. Right here. Nice. So I want to break at after this loop is over, so let's look for that load A13. And now I'm lost because it like just jumped a whole freaking page. Good job, thank you. No, I'm just blind. It just looked like it jumped a whole page. Here we go, load A13. E1FB, let us fast forward to there. E1FB on execute, Coolio, go. There we are. And so, I mean, that's no real surprise, but it got this far, which means at the very least, X didn't get screwed up, and that's good. I'm still not sure about this, but let's just keep that in the back of our head for later. All right, so this is where we are sending the configure command. So this doesn't really matter. This should just kind of happen, because it doesn't wait for an interrupt or anything. And then the set data rate to 500K BPS also isn't going to really do anything. That's down here where we start at 6807. Okay. The specify command, very similar. You just send them and forget them. So I should just be able to step over those, because those will just get tossed out into space, no problem. And FDC recalibrate. That's this guy. That's the one I care about. Step on in. And let us... Oh, well, there it is. All right, FDC select drive. Let me look at it really quick. I think that one we can also just step over, because I think it's just going to set the selected drive value and then spin in that wait loop for just a second. And it's not going to be waiting on anything, so we can just proceed. Yep, so it loads 14, stores it into that register, then does this spin, and then just returns. So I should just be able to step right over that, and indeed that is true. So where were we? We were at FDC recalibrate. And now we're load Xing hex 10. And oh boy, so this is probably more places where X is getting hosed. Do we? Yeah, we definitely do read FDC data. And then do we loop before that? Yeah, no. FDC read data, then we jump up to the loop. So yet another place where X is assuredly getting hosed. So I'm not even going to run this, because we know X is going to get hosed as a return value. So let's just keep on rocking in the free world and do the whole... This one is actually going to be weird-ish. Transfer X into A and push it, but then also immediately pull it and decrease it. I don't think we need to do that this way here. Let's see. Load A 10, and then push A, and then pull A at the top of the loop. Transfer A into X here, which of course now I'm screwing up A, so hopefully that's not a problem. Anyway, then we decrement it, and okay, so this only happens if the recalibration failed. So actually it's fine if we don't push stuff back on the stack here. Right. I'm overthinking that. So that's fine-ish. So after this, recalibration didn't fail, so we're good to take that X value and stash it back onto the step for the next, or onto the stack for the next cycle. So let's do just that. Transfer X back into A and push it. And I think I'm ready to try again after doing that. Because, again, definitely an error. Let me actually expand this so I can see what my assembler is trying to tell me. Link, don't make a stink. Very good. I appreciate you. And again, I think I'm good to just, I will reload and restart this. Apparently my breakpoints will just stay, which is super great. And I think I will just run right up to E1FB and make sure it works. And that there aren't any obvious weird screwing ups of the X. Yes. Restart. FCEUX. Here we are. Open. Sesame. Basic NES. Good. Now it's back to hanging. Excellent. Let's open that debugger and reset the whole dang thing. And I turned it off apparently. Or maybe I turned it on, I'm not sure. Let's let it get to E1FB. Cool. That's at that load A13. And let us see if we get a recalibrate success, if we tell it that it totally succeeded. So that is, the load A13 is... that's the floppy controller configure thingy, so let us step over until we get to the actual FDC recalibrate call. Doot, 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 doot. Doot. Oh, it's the one right before the RTS, right, that's easy. I did not mean to step over, and it is hung. So that's fun. I actually made it worse somehow. Let's restart this thing. Let's see why it is hung. Run up to E1FB. Step over until we get to... Oh. Let's reload this whole damn thing. Because the internal status got hosed. Basic.nes. Open it on up. Tools, debug, debugger, reset. Run to E1FB. Don't want that one right now. Step over, 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 step in. Okie dokie. Now we are at FTC recalibrate again, and let us step over, load a 10, pushed onto the stack. Yay, now there's a 10 on the stack. Then we start the recalibrate loop. We pull it, put it in X, decrement X. If it is 0, which it is not, we would branch. Otherwise, we throw it back in A, and we push it back onto the stack. Now we do a recalibrate command. And that literally is just going to throw 2 commands out into space, wait for an IRQ that's just going to magically be there, then send a sense interrupt command and get 2 things of data back, and it's never going to... You know, it should exit this loop, though, is the fun thing. I was going to say it's never going to exit this loop because this will never be 0. Or sorry, this will never be 1. Wait. No, it would never be... We want it to be 0. That's what exits us out of here, because the track 0 indicator goes low when we are at track 0. So anyway, let's just get up to this and see what happens. Especially if I tell it, well, if I have to tell it that is low, if I force that value. And that is, just so I know where that is and I don't miss it, here at E24F. So let's just step over until we get to E24F. Okay. And right now, A is 0, 0. So that would be, you know, if this was actual hardware and we had a 0, 0 and A, that would be saying track 0 has been reached. So let's see. We should not jump back into the recalibrate loop. We should just proceed to here and then return. But let's see about that. Yep, that's fine. Oh, but our stack is hosed. Right, because this is still on the stack. So there is a spot. It's just going off into space, presumably. Probably jumping to 250F, which is not a location. Yeah, 2510. Nope. So let's fix that up real quick. And let's see. So really, in either case that we are done, so anytime before RTS, we just need to pop our shit back off the stack. So let's do that. Hey, look, it's me. So pull, or actually, I guess that should happen before here because we indicate the status in A. So in either of those cases, we pull A before returning to make sure the stack is balanced. 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 Build. Build Nye the coding guy. Lovely. fcux.exe. Load up the NES if you would please. Okay, so it is no longer hanging, which I think is good. Why not, for shits and giggles? Let us comment out our lobotomized things, and I want to see if it at least gets past FDC in it now. Again, I'm sure there are much more bugs. Probably lots of things with X's getting screwed up when they're being used as indexes. That's probably our biggest thing in here. Possibly more stack unbalancing, all kinds of fun stuff. But let's at least, you know, so we can see if something's happening. I will burn this and see if the floppy gets past initialization now. Join me, won't you? And the fun thing is, even after all this, we haven't implemented, I don't believe we haven't implemented the code to actually check for overrun and underrun, which was our actual problem at the beginning of this. But, you know, now it's thorough, and we can be sure that if we get to the point that we're reading a sector, everything is set up as it should be, and we didn't have any error conditions, ideally. Right, that's the idea. So, anyway, let's find those lobotomized sections. Temporary muck. Temporary muck. And temporary lobotomization. Very good. Let's rebuild and see what it does. put it on some real hardware, and zhuzh it up. Load it at 10,000. Program it onto a chip. Then I will go eat a whole bucket of Miracle Whip. That is not a thing I will do. But, fun fact, was it when I got my first job? No. Oh, maybe it was my first job when I was, I worked for a time as a instructor at my karate school, like teaching the little kids when I was like 13 and doing some running the office. And don't tell anyone because, you know, it was under the table and illegal. But I think with like the first batch of money I got from that, because, you know, I was a 13-year-old with like unlimited freedom now, I decided the most fun thing to do with this money would be just to buy myself a container of Miracle Whip, because I could. And so I did. And then I think I ate the whole thing. And it was glorious. And I had no regrets. Ooh, that's cool. I'll have to keep that in mind. Wereworm, he says, the emulator has a cycle count if you want to guesstimate the code for reading. Sickness, actually. I will have to pay attention to that. Oh, that's fun. Okay, so yeah, I think the stack is indeed screwy, as I was worried that it would be. And so we're probably getting past initialization. Actually, let's see. I bet we're getting past initialization and then just flying off into space. Okay, it's actually hanging up somewhere weird because the floppy is not selected. Interesting. That's like the first thing it does. Yeah, no. I think it's that my stack is corrupted. I think that was just a fluke on the last one. Yeah. Anyway, back to debugging. Sorry, just thinking things to myself. Perhaps I should, just to make sure, so I can see perhaps where it is taking a shit. Before I go back to the emulator real quick, I am going to make it re-enter the monitor, well, not re-enter, enter the monitor in the first place as soon as it returns, hopefully returns from FDC init. Yes. Yeah, I'm just gonna not even check stuff. Temp remove, and yes, jump to init, not init, init. Oh, you can't see what I'm doing. How about real quick? I'm just putting this here. I'm putting a temp jump to init right after we call FDC init, just to see if at the very least we get back from FDC init, and then it flies off into space and screws up some things. I don't know. I feel like it's probably inside of FDC init, if only because the head doesn't seek to track to 0, and I think it would, you know, do that before flying off into space. But just to check, I want to do real quick first. Reprogram the doodly dotty day. Put it over here. Put it over here. That is what they say. Put it in the slot. Then build it an extra lot. Then open up this thingy and load it on the spot. Hit OK. That's all right. Then you program all the night. Even though you know this won't work, you do it anyway, because you're a jerk. Okay. Do something interesting, I pray you. Nope, it is in FTC init. Interesting. I wonder if it's because of, you know, the non-lobotomized wait loops for the IRQ. Let's see. Did I properly do that? Let's look back at those lobotomizations. Let's look for lobotomization on wait FTC IRQ. No, I mean, that doesn't affect any of the indexes. It affects A, which could potentially be screwing things up. No, but that's, I made sure that this is a thing. Ooh, actually, you know what? Not that it would significantly help, but one thing I can do here is replace this with 8.0, because that's what the value would be when we exit this loop in the real world. And let me just double check other temporary thingies just to make sure. That. I mean, this is where I was noticing that X was getting screwed up, right, in the first place. Or, yeah. So. Wait, was it? No. Hold your horses. Okay, this would be screwing up. This immediately doesn't look right to me. Now, I know I've looked back at my code. Oh, it's pushing A and then it's pushing X. Right. Right. Which, again, it's going to be super slow. And when we get back to the actual sector read-write crap, this is going to be a thorn in my side. But, ignoring that for a second. So that would be saving those registers, so they should be fine. Yeah, I don't see any reason that would screw things up significantly. Unless, of course, when you return from this, it has effed up the stack, which is definitely a possibility. And a thing that I might want to check, really, because that could be exactly what it is that this is unbalancing the stack, and on the real hardware, when I don't have this commented out, the stack is all screwy by the time we get out of this thing. Maybe. Seems like quite the possibility. Let me look at the stack behavior of this thing with these commented out really quick, because that strikes me as suspicious, because it pretty much looked like it worked perfectly fine in the emulator, right? That is what I seem to see. Let's see. Okay, and like this is definitely going to screw up X, but we're saving X in most places, and at least in that initialization code. So in the initialization code, that shouldn't be the problem anymore. But I am skeptical about this, because it definitely looks like, you know, our stack is getting clobbered and we're flying off into space over on the NES, and then running some code that is just filling up memory with a bunch of stuff. And this looks like a contender for code that hasn't actually been tested on the emulator. Let's stop all the rambling and go check it. So send FTC command. Let's build this, find where that is, put a breakpoint there. Look at its behavior in general. See if it leaves anything smelly on the heap. You know what I mean? Okay. interesting. So on here, it doesn't fly off on the space, which, I mean, there's a lot of different stuff going on here, and it's not taking the same code paths, almost certainly. And we don't know if it succeeded or failed, too. That's worth remembering. So let's find where send FDC command actually is. That is, what's the most notable thing about this? Probably load A 6804 and C0, compare with 80. Let's look for that. So the first thing I'm looking for is 6804. 6804, 6804, 6804. I think we're way past it. 6804, 6804. Show me some more of that 6804. I'd like to see you show me something more with 6804. I feel like I should be recognizing some of this code somewhere. Reading of 6800. Let's see. We're definitely in floppy territory over here. 6804. C080. Is that you right there? 6804 C080 JSR, or rather branch. That's my guy. All right. So we're looking for the FATSA fob of that, and I lost it right here. FATSA fa E356. Let's kill all these. I don't really need them anymore, or at least not right now. E356. E356. On execute. Okay. Run. Oh, reset probably would be a good idea. There we are. All right. Let's look at this stack. Already looks freaking weird. Mind you, those are... Oh, there's probably a fair number of return addresses on here. That actually makes sense. So we have, at the very bottom, we have a 0, 1. That's our counter. And then these all look like return values, actually, yeah. There's E1A9, E104, and F8, which is weird. And then, or wait. Yeah. E1A9, E104, F8. Yeah, no, I was reading that right. So there's a weird F8 in here. I'd be interested to know where that came from. And then E34E, which is where we just came from. Let's trace those backwards, actually, really quick. So what is this F8 that would be on the stack? Probably something reasonable. That's probably like an X counter or something, but F8 is a really weird count value, if I'm going to be honest. If that is like a stashed X or something. E3 for E. E3 for E. Wait. Oh, that's where we would be returning E3 for, right, C, D, E, and then we would come here. So this is, we came from here. Which is, I wonder what that is. I mean, I should know what that is, but it's not immediately striking me. There's 3 subroutine calls in a row here, preceded by a load A 08. I guess let me check where all my load A 08s are. Load A, pound number 08. Sorry, I need to escape that. Okay. Send FTC command, read FTC data, read FTC data. That makes sense. We are in the recalibrate loop. Really? the first place that's happening? No frickin' way. We're calling send FDC command, right? Yeah. That's the... No. No, no, no. 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 Okay, yeah, I'm definitely looking at the... I'm looking at a different sense interrupt. That's why. Let's look at the surrounding area to see what more we might have. I mean, there's an RTS right above it, so it's going to be a LDA08 with an RTS right above it. Not that one. That looks like a contender. FDC sense interrupt in. Oh, it's the call to this sub. Right. Okay, that makes sense. That makes much more sense. So that's popping this one off the stack. Then we would be in our frame that has the F8. Yeah. I'm amazed that things are working at all, because I would expect we return from this. This pops off, or the E3-4E pops off the stack, and then we have an F8 on the stack. But this doesn't pop anything off the stack. So when we return, we have an F8 on the stack. Interesting. Okay. Or, wait. Actually, I should be reading them from here, right? Yeah, actually. So it was E3-4E, then E1F8. That's what's up. So it's actually the 04, which does seem like a reasonable counter value, actually. 04 is the actual value that's on the stack. That's fine. Okay, so this stack is striking me as a little bit more reasonable now, actually, now that I am grokking it a little bit better. Okay. Then let us proceed with actually debugging this bad boy. Send FDC command, see if it screws up the stack too much. And yeah. All right, just refamiliarizing myself with the code here. Let us step through. So we push whatever's an A, which was 8, whatever. We pop X into A, and then we push whatever was an X, which was 4. Cool, whatever, don't care. Then we load 80 into X, which is going to be our countdown. Then we are going to start our loop, decrease it. If it was 0, we're going to get the hell out of Dodge. We are not at 0. What just happened? Did I just lose my mind? Seriously, where are we now? I mean, I know we're here, but what the hell just happened? Our shit on the stack is the same. I'm sure we're in the same place. Huh? We were way up here. Then we did this. Well, rather, we should not have done that. We should be here. Oh, I guess we did take this branch? Okay, so this is branch if not 0. Okay, let me double check this. So we decrease X if it... Oh! Well, there's an issue. How did you ever survive this? This should be checking to see if it's 0. If it decremented to 0, then we should go to send FDC command fail. What worms do I have in my brain? Yeah. All right. That seems better. I think. Let's make sure the same thing isn't in read FDC data here. Yeah, how did I screw this up this bad in both places? And how the heck is this even working in the emulator in the first place? Actually, you know what's happening is it's probably failing, but I'm not printing the fail string. I'm going straight to the monitor. is surely what's up there. Well, that's gonna hopefully improve things. Maybe? I don't know. I mean, it still doesn't explain the this thing flying off into space. Let's rebuild and do the same thing again in FCEUX, just to see how we feel about it. FCEUX. Oh yeah, let us read some comments, because my brains are squishy. Hey Dave, you are actually here with some time to spare, because obviously I am struggling. He says, testing in an emulator, what is this? Yes, just because we made a lot of code changes, and it's going to be significantly faster to debug anything that's just straight up code errors, and not misunderstanding of hardware or whatnot, just straight up code problems, which we have run into several now, through the emulator as opposed to doing it on hardware, as long as we pause and give it reasonably decent simulated inputs. Anyway, Wareroom said, I wonder if you can get the debug symbols into FCEUX. The assembler has a -G option. Yeah, like I said, I know it has a -G option, and it definitely has a thing for just dumping just symbols, which would be useful. But I don't know how to generate the nameless file for FCEUX. Is that a thing that it actually accepts too? Dave Wall says, great effort on this project. You've been chipping away. Also love the shirt. Isn't this a great shirt? I was kind of sad because this is not no shade thrown to freeware, because this of course came in my batch of all the stuff I bought from freeware. I should have gotten the black version of this shirt, because it's kind of like undershirt white. You can't really see it on camera, but like I can't wear this outside. Like you can, it's one of those shirts that you can just kind of tell, like you can kind of see the shade of your skin through it, and it's not appropriato. But it's a great shirt, so this is my lounging around at home shirt now. And I got plenty of other good stuff. Because like, man, that haiku hoodie, now that fall's coming up, I'm gonna wear the shit out of that thing. Anyway, yes, emulator. Right, that's what we were doing. Open the ROM. I think it's the bomb. See, it still amazes me that it manages to even get this far without hanging, and without any hardware implemented. But I'll take it. Let's reset, and this breakpoint should still be relevant, I think. Okay. Yes, so we are at send FTC command again. And now, it shouldn't follow that breakpoint, because there's frickin' a hex, like 7F in here, which is definitely not 0. Then we definitely haven't hit the end of the countdown here, so, yeah. Load x80, we get our count, enter our loop, decrease it, see if x was 0. It super isn't. And then load from 6804, and here's where we play the game, and we set A to 80, and we lie to the NES itself, and we say, oh, why, in fact, it was 80. You do have a thing waiting for you in the inbox, and it says, okay, well then, and make sure that this makes sense. Yeah, so if these weren't equal, then it loops back. That makes fucking sense. This one did not make fucking sense. So that's good. Then pull A, which should be our X value, and then we pop that back in X, and then pull the actual A value off the stack. Perfectly fine. And then store A in 6805, right, because this is our send command deal. And the command was 08. Yes, that makes sense. Then we load 0, 0 into A. That's our return value of all good champ. And return to our color. Super duper cool. And I think I can feel good about stepping over these because they should be fine, right? Why would they not be? And now we return. And that was, as we had figured out, somewhere back here. It was the... Let me search for LDA 80 again. Not that one. Oh wait, it was 08, wasn't it? LD... Oop. Oh god. Oh god, you're ruining this whole thing, dude. Back to searching. Load A. Hash. Escape. $08. There we go. Not that one. Not that one. This one. So now we are returning from this back to somewhere. Where are we? E1F9, which is in the middle of something. E1, I guess we can look at E1A9 is what called us. I don't know why I thought that would be useful to think about or say. So we are at the first place that... Oh wait, load A13. So we're right above the configure command. Right there. So we are at this pull A, which is going to pop this X off the stack and pop it back in X. Cool, that seems reasonable. And then we will go ahead and decrease it. And if it was, okay, so this is our sending 4 sense interrupt commands, right. So that should be all fine. Let's set a breakpoint at this load A13 after it's finished all 4 of those. E1FE. Oh, I gotta take this one out because this is our breakpoint for the send FDC command thingy, which is gonna happen a whole bunch. All right, proceed. There we go. Now we are at E1FE, which is this load A13 right here. Then let's just skip over all of these because they should be fine. See if the stack looks insane, but I actually think the stack is looking fine because, like, I think I was just seeing these return addresses before, and I was like, ooh, how'd those get there? And it's because that's how a CPU works, you dumbass. Yeah. Okay, so we do all these configuration commands, and now we are setting the data rate. Load A0, store it to 6807. Cool, cool. Then we are sending the specify command, and we literally just throw the commands at it and get out of Dodge, and now we get to recalibrate, the place that is actually interesting again. And let's go ahead and, okay, step over the last send FDC command and step into FDC recalibrate. And wow, look, more stuff on the stack because that's how a CPU works. Okay. And FDC recalibrate conveniently right here, right there. Let's go to select drive. Yes, let's do it. Should I just step over it? Let's just step over it. And if we see anything insane in the stack or anything when we return from it, then, and we don't. So we don't even need to worry about it. Seems fine. Then load A10, push it, we start our recalibrate loop. Step over, push the counter onto the stack, pull it back off the stack, put it in X, decrease it. Was it 0? It sure wasn't, Chief. So we take it and we throw it back into A and push it. And now it is back on the stack. Cool. Then we send a recalibrate command where you just send it, and then wait for an IRQ. That will be there instantly because the way we mocked that. Okay, wait IRQ, cool. Now we're sending another sense interrupt command, which I should just be able to jump over all of that. Step over, step over, step over. Super fine, stack still looks perfectly good. Then check for track 0, and I will say, yes, in fact, we are at track 0 by doing the following. Brain surgery. Load A, and then... Oh, actually, no, we want this to be 0, because, again, that is how it indicates track 0. It's a negative signal. And falls right through, goes here. This is where we fixed up the stack last fix. So we pop that counter off the stack because we don't need it no more. Then we load a OO as our all good return value and return to our caller, which was right here. And then we return yet again. Return, which puts us back all the way up at, I believe, that was the call to FDC in it, so I think we are all the way back up here, and should be good. Yeah? Maybe? Oh yeah, so this is the jump to init, I would have to imagine. Okay. So that seems fine up to that point with simulated inputs. Now, the fun thing is I don't see anything that would screw up the stack in any significant way. I don't think there were any other code paths that we really could have taken here. Stack looks fine here. We have this counter, but I mean that's just going to be on the bottom of the stack, and we'll never see that again once we jump into init. So I don't know what was screwing it up before, but I don't see anything obvious at this point after running a simulated startup in here that would make me feel like I would worry about anything unbalancing the stack and ruining returns. So let's undo some lobotomies. Okay, that's already disabled. Let's disable that. And let's disable this. And again, it's still... No, it's not possible. I was going to say it's still possible that this is not screwing things up properly with the A register, but it is. I specifically did that, so... Let's burn it and watch it do the same crazy white screen, and then I'm going to cry. Either way, what I'm actually going to do is go grab a beer. Because it's Sunday night. And Dad is in the basement and lonely. No, I've got my people. It's just funnier to say that. Also, Dad chose to be down here. Dad asked Mom very kindly, would you mind if I went down and did some more streaming? And Mom was very sweet. And here we are. So, Papa has no one to blame but himself. I'm going to stop with this language now. I bet it's totally disconcerting. It's just kind of become a thing in our household. Alright, that's programmed. Let's put it in here. Let's watch it. Fail. And read some chat before I take off for brewskis and part 2 skis. Okay. Well, not doing anything there. Neat. I mean, it was hanging. It was alternating between hanging and showing that wonderful white screen before. So I feel like we have not solved the underlying issue. Oh well, it seems to be consistently just kind of vaguely hanging now. That's cool. But yeah, not retracting the head or anything, which is interesting. Is it not properly getting the reset command or the recalibrate command? Is it not getting is it not seeing an IRQ? That's a possibility. I have to now think about all the places. So we know that the code, by and large, is good at this point, right? Because we tested that part. Like, the actual code paths seem reasonable. No obvious hang places, no any of that. Which is actually funny and annoying because the whole point of a bunch of those is to have timeouts here. So this should fail eventually. The fact that it's not is actually kind of fascinating. Let's read chat, and then I'm going to get a beer, and then we will get back to it. How is that possible? The whole point is to have timeout loops here. Anyway. Really, the only extra comment. Dave Wall says, "Haha, I know what you mean." And Dave said, "It should be noted that Heisenbugs cannot be directly observed." On that note, I'm gonna go escape and get a brewski. Please enjoy this wonderful spinning floppy disk as we think about what I could have possibly fucked up here. And I'll see you in a minute and a half. I'm going to be real honest with you. I didn't come up with any ideas while I was up there. It would be very nice to be able to see where the PC is right now, which I can't do, unless I hooked up the logic analyzer, which I'm not going to do. Okay. Wareworm says, well, the timeout isn't really a timeout. It's just a fail counter. So it waits or something. That never happens. Right, but still, it's like, it's a fail counter. Once it counts down, it should exit and go to the fail condition. Right? Right? Let's look at... Let's look at the code. Let's look at the code. Let's look at them fail counters. So the major ones are the ones for reading the command, writing a command, reading FDC data out of the FIFO, and the wait for the IRQ. Ah, you know what's fun? it could just be this, because if we have wait for IRQs happening, because this doesn't actually do a countdown. That's interesting. So that's actually, it's probably this. And why don't we put a countdown on this and watch it fail, hopefully. Yeah, Wareham says, not if it waits for EG and interrupt flag. Well, and specifically, because like if you look at the difference between this and like read FDC data, actually why is it just decreasing X off the top? That could also just be an issue. What? Am I high? Why would that have ever been a thing? There should be setup here. There should be setup. There should be setup. I was definitely high or something when I wrote this before. Okay, let's look at send FDC command. Send FDC command saves the current X value, saves the current A value, then loads X and counts down X from 80, and every time that it's not ready to receive a command, we count down. And then finally exit if it hits 0. This I need to look back at. And regardless, this never does any like failed exit, which yeah. But yeah, could just be this, because what the hell? I'm glad I went back and looked at that. What is it supposed to be doing? Presumably, I should be setting X somewhere, presumably at a label that's like between there and there. Let's see. Let me see exactly how, because I should just copy what I have here. Yeah, we need a label like send FDC check, which we don't have. Don't do drugs, kids. So, read FDC check. And before that, let us, we are fine to clobber X and A. We already know that. I feel like this may have been working before, and I screwed it up at some point on my way through here. Maybe doing this stuff. Anyway, yes, so load X. I don't know. What do we do for this one? Was this one also? Oh, it was 80. So yeah, let's give it a nice fat value of 80. And there. Now, like I must have deleted. I don't know, because this is branching all the way back to the top of this thing, which just doesn't make sense. It needs to branch to an intermediate thing after the counter has been set. Read FDC check. Yeah. Remember when I said I checked all the branches and they seemed fine? That's not a thing. That actually happened. Okay. I'm willing to give this a second shot now, though. I am going to put a similar check on this, but I would frankly be surprised if it was this, because we've been waiting for IRQs this whole time, and this code was obviously fucking wrong. And may still be, but, you know, baby steps. So let's make sure we do that same thing. I guess wait FDC IRQ check. Seems good to me. And let's do some setup. Firstly, I guess we're already okay with smashing A, but I don't want to smash X, so let's transfer X into A, push A, and then load X. I don't know. Let's just keep that 80 number rolling. There we go. Now. We can presex. Branch if it has hit 0. To... The fun thing is I haven't set up anything to fail. Like to detect failures and wait FDC IRQ check. So actually, let me backtrack on this plan just a touch. Still probably a good idea to do, but I'm going to backtrack on this for the time being, just because I don't anticipate that actually being an issue. And if it is, we'll know. Well, if there is an issue of some sort, we will know, because things are going to hang again. Okay, so we still have this intermediate layer, but label, but that is fine, because it's just the same as jumping back up here. Let's give this another go. Dave says, who wrote this? What I say when looking at any code I wrote more than a week ago. It is known. It is known. Kill these guys, murder them to death. Every time you turn off the power to an NES, you are killing a robot. Did I load? I don't know. Let's load. And okay. And program. And program. Worm says, we might need some kind of stack trace routine. No, get the fuck out of here with that business. That is... I am not doing that on an NES. That's not. No. That would be like... doing a stack trace routine would be as big as the rest of the code I've already written. Okay, maybe that's not strictly true, but it would be involved. I'm done. I'm done programming. There we go. It always seems like a dream when I'm done. I'm never quite sure. Oh! That was it. Well, I'm not saying that the code is perfectly good, but we're at the monitor. Head is retracted. Wareham says, just a very simple one, just to dump the stack on error. Yeah, that's not the worst idea. Because, not that I'm saying I'm going to do it right now, but thinking through, in case it becomes useful later, we could just, like, bind that to break, you know? Like, throw some breaks in and the error branches of subroutines and make the assign the break vector to just a thing that dumps the stack. Not a terrible idea. That could be pretty helpful. But I'm just going to keep that in my back pocket for now. Cool. Well, we got that far. You wanted to see if everything just works now? Hello, Halion the Protogen. A good evening to you. Oh, have you been on before? I'm sorry. I can only remember a handful of names at a time, so if you're not, on every other stream. Oh no, I guess you may not have been because you're asking about the Vax. I have been. It's interesting, just seeing the people who come in from different places now that, I have a video that has about 100,000 views and, 3,000-ish subscribers. Just seeing where people come in from now, and the sense of where we're at with things they have, because, like, the Vax, to me, like I said, second time I've gotten that question, I think, and I'm confused where someone would be coming in with that. Not because, you shouldn't feel put off by that. It's just surprising to me because I'm in such a different headspace. To me, the Vax situation is done, effectively. I did a whole... It was a separate project, and I didn't do a video on it, but I took the box I made for VCF, and man, this was last year, because that's where and how I met Dave, because he helped me work on it at the show. We took the white box, I made a PCB for it, I gave it to a couple people. They never talked to me again. That's not true. One I gave to June of June being June. She She just came up to me, and apparently she has a Vax that she has been meaning to play with, but it has no accessories. So I figured this is a fun reason to make a PCB. So I made one for her, and I made one for Tron, the collector of all kinds of insane workstation bullshit from the 80s. Anyway, that was the extent of that project. But I mean, the Vax works reasonably fine. Still never got that Mux card working, which is annoying. I think it might just not work. Is a real possibility. Anyway, that's the catch up on the Vax. I do, because I was given a keyboard at the last VCF for my terminal, which is also broken, much like the current keyboard I have. But we'll see. Maybe someday I'll fix it up. But that is on the back burner. Yeah, Hylon said, last I saw you hadn't posted anything in about a year. Also, damn, you've been doing a lot of streams. Yeah. Oh, and Scythe 3934 says, keep up the cool content. I'm glad that some people think it's cool. Yeah, I hadn't posted anything in about a year, and then I just decided to start streaming crap every night for no good reason. And I would love to be able to get one if I ever get a Vax, since proper peripherals for it are much harder to find than the Vax themselves. That is quite true. Not that I'm looking to go into a business for it, but if anybody needs them, they're fun to build. So, like, if somebody wants to send me, like the cost of parts for them, I still have the PCB design around and stuff. Not hard to kick off one. Oh, Wareham said, with the new old keyboard, there might be some Vax video. Legitimately, I would like to dig into that. I'm afraid of opening that keyboard. It doesn't have any screws on it. So I'm very afraid of having to try and pry it open and breaking clips and whatnot, and it skeeves me out. Not like the keyboard itself is awesome. That I don't want to make it sound like I'm looking a gift horse in the mouth. I'm just personally afraid of opening that keyboard and breaking it even worse than it was already broken. But of course, it already doesn't work out. Dave was saying he thinks it's quite a possibility that there's just a fuse on the 12-volt power going into that thing, and that might be the whole thing. So fingers crossed. But I plugged it in. It don't do jack. It doesn't even light up. Which, lends credence to there's a fuse in there and it's blown, because it's not even like doing any self-initialization stuff and flashing the keyboard lights and whatnot. So, dunno. But I would at some point. Maybe as an interim, like when I get this wrapped up, which, mind you, it's going to be months, because we'll get floppy stuff roughly working, and then I want to get basic and DOS going, and then I will call it good once we have basic, and I do want to get DOS 65 running on here. But yeah, we could do some interim stuff. I've said before, I don't really want to do any like properly edited videos anymore, just because they're a pain in the butt, and they're not like. This may seem funny because I'm obviously spending like an hour or two every weeknight doing this, but I mean seriously, those edited videos, it's doing a couple of hours a night working on the project, and then it's like 4 to 8 hours editing the video. So not fun. I mean, editing video is fun enough, but trying to get it done was just no, it's not for me. Enough rambling about me and my not being good at things. Dave says, I need to get off my butt and rebuild my Vax/Alpha keyboard adapter. I never got mine to work well enough to get into X on either host. Oh yeah, I almost completely forgot. Do it. See if you can make one that actually has like reasonable latency, particularly on the mouse. My keyboard is fine. The mouse latency and sampling is horrifically slow. Hylon says, that aside, I'm looking forward to the day AMD 64 VMS is open to hobbyists, hopefully to include GUI. Yeah, Dave was saying, I was actually talking to him about this at the show, and he says, don't hold your breath. Apparently, things are not looking good on that front, and potentially the AMD 64 VMS port is not ever going to be part of the hobbyist system, and that the hobbyist system may be dead. Worm said, but why is there no success message on the screen? Because I am skipping. I moved jump to monitor right after the FTC init code. So it's not even, it's jumping into the monitor before it's even printing the success fail. Just FYI. Hylon said, you could put the CAD file and bomb up on GitHub for people to throw Osh Parker PCB way. Yeah, that would probably be the way to go. I don't know why I'm saying, yeah, just give them a bomb and whatnot. They don't need to send me money to put the thing together. Misty Whis open square bracket says, I have no idea what's happening. I just know you've been in my community posts. What's up? You have no idea how much I enjoy that. Thanks for just, like, checking it out. Right now I'm just doing a lot of rambling because people have been poking in for some reason. Apparently this is the time to stream. We're working on... We've gotten through a fair amount of stuff, but we're basically working on, because I should do a recap, because I haven't in a while, taking an NES and turning it into an 8-bit home micro. I am, again, as I'll say at the top, aware that Family Basic was a thing. I'm aware that the Nintendo, the Famicom Disk System is a thing. These are not that. These are just me fooling around and doing it because I can. So, now you know. Just effing around and having community support to tell me where I'm writing code that is broken. And more often than not, us all figuring it out at the same time, and or me not looking at chat, somebody telling me what's wrong, then me figuring it out, then me looking at chat and saying I could have saved 5 minutes by reading chat. I like Hylon the Protogen then closed Misty Wiss's open square brackets. To which Misty Wiss says, that's a misspelled name. Well, that's fun. Oh, yeah, so, the last thing I'll say, and then I will get back into this because it is at the end of chat, and I'm saying no more after this. Dave says, the new owners aren't interested in building a hobbyist community. They don't see value in it yet. HPE/Compaq took some convincing to reopen it when the old techs were getting fewer and fewer. Yep, that blows. But I learned from Dave that apparently there are keygens out there, so that's all I care about, as long as we can keep getting access to the software. And now I'm going to eat something on stream, which I know everybody totally loves. Alright. What's on comment? Everything? See if it succeeds. I don't know. Probably not. But I feel some kind of hope. I feel some kind of hope. Yes, so all I need to do at this point is I'm just going to straight up remove my jump to the monitor and let it do all of the dirty floppy stuff that it wants to do. Yeah, so it's this guy right here. We do FDC init, and then I added this here just so that we could see if FDC init manages to succeed and or not, you know, go into a tailspin before checking everything else. So let's just remove that, build it, see what happens, live on the edge. I'm feeling it. Are you feeling it, Mr. Krabs? Load at 10,000. Hitting okay. Hitting program and going, no way! There's not a chip in the thing. What kind of chaos did I bring? Put the thing in the programmer, lock it on down, hit program, and we will run all over town. Dave says, I have no idea how that perpetual VMS license got installed on my machine. It was there when I bought the machine, I swear, officer. Okay. Highland the Protogen says, I'm feeling something, and I don't know if you're referring to my singing, but I'll take it, whatever it is. Okay, this is a big test. We're just gonna let it run the whole thing, doing init, trying to read a sector of the floppy. This is a big try, hoping all the parts kind of work together maybe. All right, I will take that. So I don't know where it failed to read the sector, but works for me. I suppose one thing we can do... Well, let's look at the code, because I've already forgotten all of the places where we can fail in reading the sector. So let's look at them and see if any of them would leave some nice breadcrumbs for us. Because I intended to leave myself some nice breadcrumbs. Yep, we reselect the drive, which is whatever. Read sector. It can't be the overrun, underrun. I never added that code, I don't think. We still need to. That's important. But regardless, so... Okay, cool. So that means it tried to do it twice, right? Oh, actually, interesting. Ooh, actually quite interesting. Because the whole thing that I did here was I wanted to set it up so that it, when it failed, it tried going to, it totally resets the floppy drive and resets and retries everything, which is kind of what they say that you should do if you encounter an error, is just reset the floppy controller and redo everything. Which it's supposed to be doing, but interestingly, what happens is, if we call read sector, and then we check to see if the value in A was 0, because if it is 0, that's our message for all good. It was super fine, everything went off without a hitch. If it did not match that, then we jump back to attempt read sector, which is all the way back up here, and does a pull A, which this could in and of itself be our issue, actually. It pulls the counter off the stack, decrements it, and then goes to read sector fail if it was 0. But here's the thing. That should be happening at least twice, and it should, at the top of each of these, be printing the sector read attempt message, and I only saw one of those. So that is of concern. You want to see if we can mock that? Maybe? Because, sure, I believe that it would be failing, but that, in and of itself, is kind of concerning to me. Anyway, let's just keep that in the back of our heads and just go to FDC read sector and see... Sorry, just thinking. Yeah, because the only place it jumps to print that fail message is up here. And let's just double check if this was 2... Oh! Because it's going to die at the top of the second loop, actually. That's let's do a sanity check on that one. That's an easy one to do. If I up this to 3, then I think we should get to 2 loops before it dies. Right, because it decrements it the first time through, so it's 1 here. And then when we get through the second loop, it would be at 0 after that second decrement. Right. So let's just make sure that theory is true really quick before we dive into what I was thinking in the first place, so that that thing that I was saying, let's keep it in the back of our heads, I can remove from the back of my head. Because I can keep about 1.5 things in my head at any given time. So the less in there, the better. Load, move the chippy, take the chippy, put it in the other chippy. Reader thing. Hit the program button, hit the program button. Do a little dance that it succeeded, pop it out of the programmer, put it back in the thingy-madoo. It is now in the thingy-madoo. Floppy power. And Nintendo power. Yeah, there we go. Okay, good. So whether or not the failure is reasonable or not, it still tries twice. Good. Okay. That is sane. I am happy with that. Why am I taking the floppy out of here? Um, reading. Oh my goodness. Okay, chat is picking up, and I am not a fast man. Oh, it's the follow up to your SpongeBob reference. I forget what I say 2 seconds after I said it. Now I'm on the page. Wareworm says general failure. Even if you fall fat on your face says Halion. You're still moving forward. An ad for DIY Network photo contest of all places. But very, very relevant to this channel. Hypnopunk says good luck. Thank you, Hypnopunk. I really appreciate any energy sent my way. Makes me feel good. Makes it even more fun to do this. Misty West says big brain stuff. My monkey brain is getting stimulated. Yeah, feel free to hang out. Firstly, again, me and Dave point this out constantly. We just bang on stuff until it starts working. That's all I'm doing right now. I'm not a particular whiz with this stuff. We just keep banging on it, which seems to be entertaining for people who don't do that kind of thing. And I would like to think that it would inspire anybody who finds this interesting to start banging on stuff themselves, because you would be amazed what you can get accomplished if you just pick up a thing, say, how the hell does this work, and how the hell can I get it to do something, and then just keep, like, looking up shit on Wiki and Googling data sheets and stuff until you made it do something. It's a very satisfying feeling. You're more capable than you think. Misty was said, activate. I'm going to say that from now on. Dave said, I only have my vaccine because Deck was terrible about picking up equipment for repair and abandoning it at their field office. Then moved out of said office, leaving equipment behind. Yeah, we already had this conversation on how I think Dave, all of your Deck stuff you got for essentially free. And then the one, I always wanted some kind of mini computer situation, so I broke down at one point and spent $1,000 getting my microfax. Do not recommend. I mean, like, it's cool to have it, but that was a silly amount of money to spend on something, and it just shows how much stuff has shot up. And I probably could have gotten a better price, but I just offered the guy $1,000, and he said sure, because he was looking for a little bit more than that, and I was like, this is already a low ball, and he said, I'll take it. And then he was a nice older man. I don't know if I've told this story on stream before, but this is the proper venue, and I almost forgot about it. So if you're here or watching this particular episode, count yourself lucky, because this story is awesome. So I go to I see this thing listed on eBay. It's in Columbus, which is, you know, like 3 hours away from me. Not Columbus. It was the other one, the one on Lake Erie. Oh no. Cleveland. At least we're not Detroit. Which we're still very salty about. Thank you, Cleveland Board of Tourism. Anyway, so it was in Cleveland, so I was like, oh, I'll drive 3 hours for that if he'll knock down the price a little bit. Anyway, so I drive to Cleveland. I go to pick it up, and you know, I've never been here before. I'm feeling out of my element. My wife is in the car. I'm like, stay in there. You know, I'm not expecting anything bad to happen, but just like, I'll go. I find the house. I walk to the front door. I knock on the front door. This nice old man, probably in his, I don't know, might have been in his like late 70s, could have been early 80s. He was an older gentleman. He sticks at the door, and what I hear is, "Oh, you must be the dickhead." And I just went, like, I was taken aback, but I was like, okay, you meet all kinds of people. Maybe this guy is like on the spectrum or something. You know, just maybe he has Tourette's. I don't know. I'm just going to pretend I didn't hear him call me a dickhead and move on with this transaction. And so he's super nice. We're chatting. His son is there. His son helps me load it into the car. We're talking about stuff. It's just a nice time. Very nice people. It was all great. I'm driving home and I'm feeling like they were so nice, but it was so odd. It took me like a full week to realize he had said, "You must be the deck head." As in deck, as in digital equipment. And I just have to wonder what he thought the look on my face was, because I'm sure I just went like there must have been a jump. Anyway, it's not a very good story, but hopefully 5 of you out there will enjoy that one, because, oh man, it was a funny realization. It wasn't particularly funny at the time. It was just, oh my god, what a moron. Yeah. Anyway. Halion says, microvaccines/vac stations aren't too expensive on eBay. Really? The question is, what are we counting as not expensive these days? Because I feel like you might be talking $150 to $300 as being relatively affordable for collecting old equipment. And let me tell you, from people like me and Dave who started this hobby way back, like from the origins of collecting old computers, which really is like all of a sudden in the early 2000s there was all of this like this glut of like old school computers and big iron that was useless from the 70s and 80s and stuff that just popped out onto the market, and it was basically free. It was like scrap value, and that was the funnest. You could have these machines that would have been like tons of money and unobtainium, and suddenly you can just get them for basically nothing, and it was a thrill. And now it's become that I feel like people who are like getting into the hobby of collecting old computers at this point, it's like, oh yeah, I found a good deal. It's like $200, and it's just so bizarre at this point. And I still like this stuff too, and I'm into it. So like, I'll spend a little bit of money every now and then, but it's a little madness. Taco Man says, "Good night, guys. I'm gonna get some sleep. Work tomorrow." Yeah, me too. Honestly, I mean, I'm going late for fun tonight a little bit, but I will have to wake up in the morning. Thank God for working at home. Halion said, "Good night to Taco Man." Halion says, "That's about 1 1/4 more things than I can. .w. That's on me for not understanding that. Misty Wiz says, "Progress. Should fix my name or be lazy and not do it." Halion says, "I vote fix it." I actually vote don't fix it. Not that I like to go against my handful of fans, but I kind of like it for reasons of just pure dorkiness. Dave says 4000 series vaccine are stupid expensive. Yeah, I feel like anything that's not, a desktop machine is basically unobtainium right now. Halion says, "Oh wow, lol." Oh damned pin pen murder. Yeah. Halion says to me, "It's the desktop ones, which I see under both names. I found a few on eBay for $250 to $300. Yeah, that's not cheap. That is not. I even like right before things really started picking up in price all of a sudden. When would this have been? Like probably 2010, 2011. I bought a HP Visualize J5600 workstation off eBay, just because it was a lark and it was cool because they're PA RISC processors, and I was super into weird Unix systems with weird processors at the time. And I think I got that for under $100. And even on that one, I felt like I was spending a whole bunch of money. You can't get those anymore. I mean, you can. Every now and then the J5000s show up, which are broadly the same machine, same case, slightly different configuration. And I mean, they try and sell those for like $400, $500 these days. It's freaking crazy. Werewolf says, "Now I imagine him getting punched in the face for getting it." Never, 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 never. Everyone is cool. You will. I am a hippie, touch grass kind of person, man. Highland said, "Of course, it's beyond my means right now, but one day you'll find a deal. Hopefully, someday. And if you're willing to, if you like the thing and you're willing to drop a couple $100 on it, like, by all means, like, if you have an income and you want to give yourself a small present, that's not like an unreasonable thing. It's just surprising at this point the way prices are. And you said you could hold a thing and a half in your head. I see. Oh, .w. is dejected furry face. I have actually not seen that one. I know the other ones, the _. That's old school. Of course, the smiley 3. I am familiar with ooh. Somehow I've never seen .w. Unless that's supposed to be some take. Oh, I see it. Yeah, that is a take on uwu. Oh no, Misty Wiz says, oh no, Chromebooks on low power. I might get on my laptop to watch. Hang on. Oh, Highland says the others are all $700 or more. Yeah. And Unix plus weird processor equals heart. 100%. Misty Wiz says, I just got our old PS1 we found in the attic. Heck yeah, I'm a big PS1 fan. Didn't as a kid in the 90s, I did not grow up with a PS1. I had a Genesis, and then we got a Dreamcast when that came out. Big Sega kid, but we picked up a PS1 at one point, and there's something about the graphics and shit on the PS1 that I just love, and of course the library of excellent games, because I'm a big Final Fantasy person. Not like a giant Final Fantasy nerd, but I really like some of the Final Fantasy games, and I am a huge original Resident Evil series fan. So, love those games. Love Silent Hill. Love the original Tony Hawk's Pro Skater and Pro Skater 2. Classic games. PS1 was such a good platform. The PS1 was my first console and baby. Depends on when you got it, I guess. Because the Genesis was my first console, but we had it very late in the game. We got it as a hand-me-down from a coworker of my dad's that he bought it off of. So because I think we got the Genesis in like might have been 97 or 98. He's a Genesis Chad. Dreamcast heart, of course. I mean, if you owned a Dreamcast, you're a giant, weird, cast-out nerd who can't stop talking about how great the Dreamcast is now. I know, I'm in that camp. You can't, if you owned a Dreamcast, you're in that camp. That's all there is. Dave says, hides Dreamcast homebrew. Nope, nothing to see here. Anybody, look, I'm not an expert. The whole piracy killed the Dreamcast thing, I think, is total, absolute horse shit. You hear that all the time. It's because of the 32X and the Saturn. It's because Sega went and shot their own dick off. Okay, this is just turning into a story night. I will get back to this, I promise. But other story time is when I think I must have just finished Sonic Adventure for the first time, and so I was like 9 or 10, and I was so excited about it. So I wrote a letter to like the Sega mail-in address, because they had those at the time, and I wrote this thing where I was talking about, ooh, Sonic Adventure was open-ended. I think it indicates a Sonic Adventure 2, and here's my design for turning the Dreamcast controller and VMU into a portable game system that you could just pop the whole cable off. Like, it was so incredibly dorky. And then I actually got a letter back. It was probably the best thing that happened to little 9-year-old me's entire life. And so it was just, some intern there wrote me a letter back just about like, wink, wink. Yeah, there'll be a Sonic Adventure sequel, maybe. And thanks for sending in your designs that we threw in the trash. And anyway, I was over the moon. And then I think it was the day after I got that letter, I found out that the Dreamcast was canceled. And I was so sad. And that is why I will always be a Dreamcast fanboy. Yeah. Okay, I gotta catch up, and then I gotta get back to this project, and then I gotta go to bed someday. You wrote DC Doom? Dave says he wrote DC Doom. The more I learn about you, Dave. Good lord. Among other fun things for Dreamcast, including almost all of the homebrew menus people used. Holy shit, dude. Okay. I am glad that you're my friend, and I learn cool things about you, like, every single time we meet, and you know that on my list of things that I'm gonna do this to, the Dreamcast is on there, and we're installing NetBSD on it, and installing ISA peripherals, and all of that shit, and we're gonna make it into a Unix workstation that boots off the hard drive. You know that, right? That is happening, and you are gonna be my wingman, apparently, as you teach me SH3 assembly. Okay. Hi on the Protogen says, Sega having an Oathkeeper size arsenal of foot guns killed the Dreamcast. It not having a DVD drive certainly didn't help, what with the PS2 being a thing. Yeah, it was just, like, that was just a horrible timing, really, with DVD not really being a major thing until after they released the Dreamcast. And so in development, they wouldn't have been thinking of making it DVD-based. Misty Wiz is back and says, I'm going to work on my game. See ya. Have fun. At some point, I'm going to write a game. I say every day since I was 11 years old. Hylion says, to be fair, unsolicited designs usually get thrown away for IP reasons. Yeah, no, that was my joke. It's like, you know, I was 10 years old, and I took seriously that they were going to look at my design. Hence the joke being that, like, obviously they threw it in the trash. That's what I would have done. Not to be mean, it's just like, duh. Dave Cooter said, oh, that's the name that I have been trying to think of for the longest time. DC Navi. Yeah, man. You know, did I tell you about my Break the Dreamcast Switch? I think I talked about it early on in the stream series, but yeah. I got the DC Navi guy was a real inspiration, and he was working on a thing where he had like found replacement or like the same spec flash ROM as the one that was in the Dreamcast, and he was making his own BIOS for shits and giggles, and he had piggybacked the flash ROM that was in there with his own flash ROM, and you know, with a chip select toggle switch. And I had no idea how I was going to program my own chip, but what was one of the things that I was the most proud of for some weird reason is that what did I do? I think I lifted the chip select leg and attached it to a toggle switch and made it so that I could boot the Dreamcast up with or without the BIOS, which I was just very stoked about at the time. And I had this is the whole thing, is I would love to, this would be a whole thing. I think it's more doable now, because like I know more about this stuff and what I'm doing. What if I made a replacement BIOS that boots from the hard drive? That's the thing that I really wanted to do back in the day. That could just like directly boot NetBSD or whatever I think it's NetBSD, directly off of a connected hard drive that's sitting on the ISO bus that is connected to the modem port. Yeah, that's the dream. That is the dream. Was it SH4? Saturn was SH2. I think I said SH3, so I just bridged the gap perfectly. Hylion said DC Unix would kick ass. It exists. There is a NetBSD port for Dreamcast. Has been for a long time. Also, I didn't realize SH4, because I did do a little research on it recently, that SH4 has an MMU on it, and it's just nothing uses it on the Dreamcast, but it has an MMU, which I actually didn't realize, which makes sense, because I didn't think about that before, but NetBSD conspicuously lacks a no MMU mode, which even Linux has now, because they long ago ingested the UC Linux codebase. And that is a thing that NetBSD still lacks, which is funny, because it is the operating system known for running on everything. But yeah, so like it's a proper RISC workstation with the MMU and all. Hylion said, I just want one with the beta boot screen and a custom colored swirl. Yeah, I know that was definitely something that DC Navi was doing with their custom BIOS. Dan Pot, yeah, man, that name comes right out of the back of the history in the brain stem of my brain. That tickles my brain in a funny way. Wrote LibDream and CallistiOS. Yep, that's the one. Yeah, it's one of those things where I've been wanting to like look that back up on archive or whatnot, and I haven't been able to because I couldn't remember any of those names. NetBSD, I think, has the drivers already for ISA on the G2 bus. That's my understanding. I believe that was merged in when the Japanese guy built that hardware, because several people ended up building that hardware. It was kind of a thing. Dave says, SH4 was the first superscalar pipeline CPU I had to debug and wrap my head around delay slots and nastiness. That sounds fun. Yeah, because that's... I've never messed with that, but like that and MIPS and stuff have the thing where the super scalarness is like basically part of the ISA, right? With the delay branch slots and whatnot. I'm not super knowledgeable, but that seems fascinating to me. Is it possible to make use of the Dreamcast MMU or no? Yeah. I don't know if there are like any NetBSD drivers that specifically do anything to it, but yeah, it's totally accessible and it's pretty well documented. I have done some Dreamcast playing around with Dreamcast development, but not since I was like literally I was a teenager when I was doing it. So A, I didn't really know what I was doing very well. The fact that I managed to get anything running at all is a miracle. And B, I have forgotten all of it, and I very much look forward to getting back to it at some point in a couple of years, based on the rate at which this is going, which currently has a velocity of 0. Halion says, fondly regards Marcus Comstedt's website about the Dreamcast boot process. Yeah, there were some classic resources, man. Good memories. Dave says, what do you mean you execute 2 instructions after the jump instruction? Yes. Well, like I said, I think the only reason that I really know anything about delay slots is because Ferris, which I don't think that's actually his name, and I follow him on Twitter, I should check, and he's a very nice guy. He was doing his own streaming series on years ago on writing an NES emulator from scratch in Rust. That was a cool series. But since he was implementing the MIP CPU that's in there, he was going on and on about delay slots. And I said, I have never heard about this before. And I was fascinated, but I've never looked into it. Okay, all right. How do you folks feel about, firstly, taking a quick second to re-remember, this just said it failed, right? Yeah, that was the whole deal. Yes, it seeks ahead. It thinks and thinks and thinks. And then tries twice and fails. Very sad. So where's it failing? Here we are. There we go. I am inclined... I'm almost thinking... Okay. Easy thing first. Let me just go look at where this can fail, see if there's any obvious spots, and see if there's any obvious reason why it would fail because we're setting things up wrong or something. And then, if there's nothing obvious, I think I will do Wereworm, who I don't know if Wereworm left us or not. Was Wereworm saying work in the morning? Maybe. Somebody was. Anyway. Do that, maybe do that, throw in a break on error conditions and do a dump of the stack. Maybe. Sounds like not the worst idea, because then at least we can see where we threw an error. Yes, so, code. Very much. So we get as far as, we know that this much works, FDC init works. We know it's not an init failure, firstly because we walked through that code and it seems fine. And that is a different failure message. If that failed, we would branch to FDC init failure, which is down here, which prints the FDC init fail message, which is not what we're seeing. So, I doubt it's FDC select drive, particularly because that is also called an FDC init, so there's no way it's that, because there's really no way for that to fail, honestly. It just turns on the drive motor, turns on the drive select, and waits a second, and that's literally all it does. Okay, so, FDC read sector. I guess let's just go to it. FDC read sector. So we set up our buffer. Yay. We know that works fine. Read sector command, MFM mode. Send FDC command. Okay. So I'm immediately seeing, like, it could fail here. Like, it could fail so many places. like that could just not work. So I'm leaning towards actually maybe doing that whole. What if we just Here's a thought actually. What if we? I think the easiest way to go, instead of like writing a whole dump code, we can just look at the stack because we know where the stack is. It's fixed, and there's the question of. I guess maybe here's what we'll do. I will insert a break instead of returning an error code in places that can return error codes. And I will just save the stack pointer somewhere. And that way we know where the end of the stack is right now. And then just hang. That's what I'm going to do. And then, or maybe not hang, drop to the monitor. That's what we'll do. And then we can just look at what's in the stack manually with the monitor. That sound good to you guys? I'm going to do that. All right, so where are the places that things can fail? The main place things can fail is, theoretically it could be the IRQ, but we've never seen a problem with that. Read FTC data fail. That seems like a place that would fail. So let's just drop a break right there. Temp. And that's that one. Send FTC command fail. Again. Just break. Should we break after cleaning up the stack? Why not? Oh, that was just to unbalance the stack. I was like, I like how I'm pulling A and then immediately overwriting the value, but no, that was just to balance the stack. All right, so there's that, there's that. I'm not sure we have any place else that actually detects. I guess we have this FTC read sector fail, which if it's that, I mean, and really that only gets called if read FTC data doesn't return a valid value. So that's it. I mean, it's if this returns a bad result, it goes to the read sector fail. So, let me just read this read sector code real quick before we just go flying off implementing that break handler. Okay, set up buffer addresses, send command, if not jump to fail, 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 send command, if not jump to fail. Jump over this local funkish thing for read sector fail to proceed read sector data, load Y. Oh, well, there's a fun thing. That's fucked. What? Oh, wait, right, because read FTC data returns the status in X. That's why. So this is the same thing. Read sector fail if... wait, why is it DEX? Oh, right, because I did this whole clever thing. Right, that was supposed to be clever. Because if this returns 0 in X and we decrease it, it will be FF, which will not be 0. And if it was 1, then it will be 0. Yeah, that was the clever thing we were doing. Could be that. Might have been too clever for my own good. This might not work the way I expect. Moving on. Then we store this, increase Y. If Y has wrapped, or rather if Y has not wrapped, we keep on looping, which will give us 255 reads. And then theoretically same thing here, and all I'm checking is to see if we have anything besides read FTC datas and send FTC commands that could possibly send us into the fail condition, because if not, then I'm good to proceed to implementing the break command, because that's the only place that we have failures happen, really, is that it boils down to that. So anyway, same clever thing, read FTC data. If it was 1, then we jump to fail. Otherwise, we keep looping and storing and looping and storing. Then we read the result bytes, which again looks like the same thing. Get the data, if not, read sector fail. 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 Success code, there you go. So yeah, we don't need to put a break here or anything. We can just put it, we can just handle the ones that are in the read FTC data and write FTC command thingies. So let's implement something for break. Firstly, let us remember where the break vector is, which I'm sure Dave could tell me off the back of his hand, but I'm going to have to look up. 6502 vectors. Sure. Here we go. IRQ and break are at FFFEFFFF. Oh, fuck. Damn it, damn it, damn it. That's for the IRQ too? But I'm sure I'm getting IRQs from the video and whatnot too. Damn. Well, I mean, that's not so bad. I could just jump in it. Why not? I don't really need to do break. No reason I can't just jump to init. Right? Overthinking it. Jump init. And we already know it's gonna throw an error, so all we care about is also, actually, this, we also need to store the stack pointer, which there is a command for that. It's like TSX? Is there TSA? No, there's not. There's just TSX. Interesting. Transfer stack pointer to X. Okay, so we'll just do TSX and then store X somewhere. So TSX temp, and then store X. I don't know. We'll make a new 0-page thing. Why not? SP valia will be 1B. And we can check that when we get into the monitor. Anyway, let's look for BRK again. There we go. Firstly, let me look back and make sure that this was all good. Make sure I get a temp in there. Okay, so when we get here, we take the stack pointer, throw it in X, take X, store it in SP value, so we can view it and then jump into the monitor. And then let's do the same thing over here instead of break. There we are. Is that whenever we hit a failure here, we will store the stack pointer value and fall into the monitor. Does that seem good? Does that seem all right to y'all? Seems good enough for me to try it. And then we can work backwards from what called us to figure out where the actual exception happened. Dave says, break causes B to be set. I think in the P register contents written to the stack, but I can't remember for sure. Yeah, that seems rightish. I shan't fool with it right now. I think this is probably the easiest and most sensible way to go at the moment. Because, like, there's no particular reason I would want to use break, except that it's a short way to fall into some code. Yeah. Load, load, load. Load, load, load your code gently to the buffer. Merrily, 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 merrily. Oh, why must I suffer? And I see I have a fair amount of chat to catch up on. Oh, tonight is brutal. All right. Let's try and program and talk at the same time. Oh, also, I'm sorry, Holly, now that I'm looking back at it, you said, is it possible to make use of the Dreamcast's MMU or no? And for some reason, my sleepy beer brain thought you said VMU. Yes, you can totally make use of it if you're writing your own custom code. There'd be no reason to use the MMU if you're just writing a game, like it doesn't really make sense to use it, but I mean, NetBSD uses it, so. And I'm sure there's a Linux port and stuff too, but NetBSD is like the most polished thing. Oh! Okay, I do have some things to read. Firstly, Hollion says, I should learn Rust. Trey, go help Hollion learn Rust. As you can see, Trey has the R in his logo, which he has pointed out to me, and he said, go learn Rust. And I said, I tried, but my brain is too dumb. And it's a great language, so I would recommend Hollion. Go learn it. It's cool. Yay, error handlers, says Hollion. Wareham says, Monday is a national holiday here, German Reunification Day. Oh, is it not you that was in Poland? I thought that you were... Or, I mean, Poland could celebrate German Reunification Day, I guess. But it must not have been you that was in Poland. Trey says, hola. Good to see you, Trey. And Trey says, we gonna learn how floppy drives work? And Trey says, write the end of stack to the 0 page. On it. Yeah, Trey knows what's up. Send command. If not, jump to fail. Track 0 2022. Get it on a t-shirt. And then Dave was talking about the B-bit. BRK is a -OS optimization. I suppose so. Hollion said, what about in NetBSD? Yeah, the MMU is used in NetBSD. Because you can't separate process spaces without it, and NetBSD must have properly separated process spaces. Okay, we're gonna monitor. So with the amount of time that it takes, I feel like it's a timeout somewhere, is my first guess. Which could totally be an us configuration issue. Yeah, Trey says, read the Rust book, then try doing a small project. The Rust book is good. I've gone through a chunk of it, and can recommend. So that was 001B is where our stack pointer is hanging out at. And that says that's an F7. Cool. So if we work our way backwards from... Well, actually, I guess let's just go to... I guess we would start at F7 and work our way forwards, wouldn't we? And I can't remember if it pre-decrements or post-decrements, so I'm just going to start at F7. And we'll go from what makes sense. So, 01, that's a 2. 01, F7, set that address, do some dumpage. Okay, so that's that. So, yep, that makes sense because that 02 right before that bunch of Fs in uninitialized memory, that 02 is our attempts reading a sector counter, which should be 2. And so our call stack is E1A9, E225, and then that looks like it's gonna just be a value, that OE, a counter for something. Then E245. So it would appear we got called from E245. So let me write this stack down over here and we can work it out backwards in the code. And this is going to be annoying because I can only either share my screen or see the NES, because I use the OBS preview to see the NES. I'm looking at exactly the same screen you guys are when I do that, so sorry. I'll just do that first, so I'm not swapping back and forth. Open up my trusty old notepad, and my call stack was working in backwards order. E2, that's a 4-5, right? 4-5. E2, 4-5. What looks like a standalone 0E. Then E2, 2-5. E2, 2-5. E1, A9. And then our good old friend O2. So we're not too deep into calls, which I guess is probably good. All right, so let us... Oh man, I don't have Fuchs open, which would have been quite useful because that has literally the code and the addresses for it in here. I guess I will just open it up myself. I realize I could also just open it up in like a decompile or something, but FCEUX seems like the easiest way. Open basic.NES. Open tools. Debugger. There we go. And now I can compare. So E245 is where we got called from. What does that look like? E245. Well, that should be the jump into the monitor, right? Oh shit. Oh wait, no, I dumped the stack pointer at the time right before we jumped into the thing. So actually everything, assuming the stack is all balanced in the monitor code, which it better be, then all of this part of the stack will be preserved. Right, okay. I was worried about that for a second. But it should be untouched. E245. E2. 4. Okay. So that probably makes sense because this is 3, 4, 5, and then we would be returning to here, and that is inside of a... Interesting. That's inside of a sense interrupt call. Huh. And that is in the call to... we might just not be waiting long enough, honestly. Because this can take a while. So we might want to just make this wait longer, and it might be fine. But this should be the call to get command. Yes, I believe so. Let's look for this. So that is in, what is that called? Sense interrupt. It's here. So yeah, it's this call right here, this send FDC command is where it is failing. So that's fascinating, but let's go up the stack to see where that's getting called from. Real quick like. So here's our OE, which might make more sense once we pop this off the stack. So if we return to... No, that is weird, isn't it? So E245 is where we were getting called, which is... E245 was... So we got called here, and would be returning to here. So this is where we jumped into the send command, and it took a crap. So it wasn't ready for us to send it a command yet. So I wonder if maybe we just need to wait a minute. Like if it's not done recalibrating and everything. I might want to just put in some more waiting. Though you'd still think that... Oh, well, I was going to say, you'd think that by the second try, it would be all ready to go. But no, that fully resets the floppy drive and does all of the previous steps over again. So we might just not be waiting long enough. Maybe that's all that's up here. Anyway, so if we return, when we return here, what we have on the stack is OE, which is odd, frankly, because once we get back here, we resume here, call this subroutine, Oh wait, no, I'm looking at the wrong code. This is the call that's inside, that's directly, literally written. It's not this FTC sense interrupt one. It's the one that's written inside of the recalibrate loop. Yeah, okay. Really? No, it can't be the one recalibrate. We went through recalibrate. Recalibrate is fine. We tested this. Let's look at the surrounding code. So, whatever that is, but it's going to be immediately preceded by a load A07, then a JSR, then a load A00. Let's just look at all of our load A07s. Load A07. It's a recalibrate command. I don't know that this is exactly the right spot, but that looks right. Yeah. It's failing in the recalibrate command. Really? 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 Because, I mean, the rest of the stack is pretty easy. So this is our, I suppose, our counter for how many times we've tried to recalibrate. Yes, because it starts here. So we've done a couple of moves back. That is so odd because we just tested that FTC init completes just fine. Now it could just be that this is, you know, spurious and we're not giving things enough time, and this is actually not our real error, which could be interesting. So let me go back through this. Let me just finish going through the stack. If that makes sense. We would pop that off somewhere down here. Yeah. Pull A. Blah, blah, blah. Set it to 0. Return. If we were returning. And when that happens, so that means this would get popped off and we would be going back to E225. E225 is up here. So that would be the end of this one. So that's going into this return here, which is right after a load A21. This is in our reset FDC code for sure. But load A. That one. Yeah. 038521 hut hike. Send FTC command, and then it goes into recalibrate where it takes poop. Well, where it is currently taking a poop. Okay, so that makes sense. Because also I think that's the only place it's called from. And then that is called from E1A9, which is, I'm sure that's back up in our main startup code, so no surprises here. So that's funky. And let me, now that we've checked that, I am just going to really quickly reset the whole deal and see if we get a failure in another different fun location or a different stack trace, because spurious issue maybe? I mean, at least failing at that location. I still expect it to fail somewhere. Okay. Let's look at that whole stack. O1B, is that correct? Okay, no, it's probably going to be exactly the frickin' same. What on earth? It got past FDC init just a little bit ago, and now that seems to be where it's taking a crap. Anyway, let's do that old dumperoonie, which I now know is actually at F8. O1 F8 set address. Does that look exactly the same? E248. I will look at my thing in Notepad and let you know. E248. Yeah, probably. E248. Interesting. It may have gotten a touch further because it was E245 before. But then the rest I think looks the same. So we've got the OE, we've got the E225, E1A9, and the O2. So it is all the same, except it made it slightly further. So, yeah, let's increase the times on those timeouts for get FDC and set FDC, because I think it's being flaky there. And it would be cool if that was the only issue, is just that we're not waiting long enough in those. So let's do that. Hello, computer. Do go back to the code. Let's look for the definition of send FDC command. And let's just ramp this all the way up to FF. And let us also where can I insert a bunch of NOPs without making this super slow on the first try? Because that would be nice to not have that happen. Well, for now, I guess. I'll just throw in a few NOPs. NOP, 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 NOP. 4 seems fine. And same thing in read FCC data. Let's up this all the way to FF. And same thing, throw some NOPs in after this. NOP, 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 NOP. Just slow it down a bit. And then hopefully at least actually get a failure that is in inside of the sector read logic. Pop out the chip, give it a dip into the programmer. Then we will proceed to feed it some numbers. Load it up. Hop it up. Yubidoop. Brogaboop. Yay. Done. Power here. And read some things. Tom says go to sleep. You are correct, Tom. If you are awake, you also go to sleep. I work with Tom. We have to both be able to work tomorrow. What would a value be doing on the call stack? So, computer science facts for you, because this sounds like it could be an informative moment for you, Halion. The stack holds more than just return values. It holds all kinds of stuff. On a simpler processor like this, it's, you know, on the 6502, it's almost like no, very few hardware functions and commands, like subroutine calls and stuff like that, put anything really more than the return value on the stack. With modern CPUs, like even with just subroutine calls and stuff, you get a ton of stuff on the stack, especially with interrupts. You get, and on the 6502, you get more stuff with interrupts too, but you get a lot of stuff on the stack. But so, point being, anything can be on the stack. The stack is just for shoving data onto and popping data off of in a way that is convenient if your data is stack-oriented, including things like subroutine calls and whatnot. But you can just shove random values onto the stack. So if you need to keep track of them, you can just shove them onto the stack. and that's what that's about. That value was on there because it's a countdown counter thingy that we don't want clobbered. Halion says, I use Messin myself. I don't really do NES dev in general, so I was told this has a decent debugger, and I am using it for that reason. Oh, and Dave already gave you a reply. The stack is the stack. As you push stuff to save across calls, it pushes further down the stack, so you get data and return vectors mixed. Yes, yes. And Dave says, so when you call a function you know is going to clobber a register, you push that register before the call and pop it after the return. Indeed. Explained it better than I just did. Omaha. I have no idea what that is a reference to, but I like it. Yeah. Sounds like it could be a timeout. Probably is. And does the status register have anything useful? What I found is that the real useful status register values you get at the end of floppy commands. So for the most part, stuff like this, it's probably just that the floppy controller wasn't ready by the time we ran out the clock there, because it's probably a marginal thing. You can see on that second run it got a little bit farther because it looks like it's a little marginal because, you know, timings and stuff in the real world. So yeah, this I don't really need anything in the status register, but even then, the status registers that you can read directly on the chip don't have a lot of super useful information. You get at the end of certain commands, you get some special values back, and those tell you the really useful stuff that went wrong. See the last couple of videos for interesting status register values in there. Okay, I guess we can turn this on. Okay, so let's look at that stack. Oh, you were calling out addresses and went, like, see, this is the thing, is I am not a sports person, so I don't know how, I still don't know how Omaha relates to that, unless that is just the Omaha team. That post got eaten the first time I tried to write it. All right, let's look at the old stack, see if it got any better. Oh, 1B. U-doot. Wow, look, F7. Amazing. 01. F8. Udoodly-doo. Dump, 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 dump. And look, it's E245 again. Amazing. Interesting, actually. What? I gave you so much time. I gave you so much time. Oh my god. Oh my god, we've been going for almost 3 hours. Okay, then you guys are going to have to be angry at me, because the title says or bust. So we're just going to have to make the next one or bust or bust. Because holy shit, I have to go to bed. Holy goddamn Christ on a goddamn cracker. You guys, what the hell happened? Oh, okay. I'm being filled on sports things. Longtime NFL quarterback Peyton Manning liked yelling out Omaha in the pocket during his tenure with the Denver Broncos at the end of his career. Thank you for sports facts. I appreciate this. I always wished I could get into sports just to, like, it seems like an interesting thing to be into. I don't know how to say that any less dumb. Not just to like fit in with people who do sports stuff. It just seems like it could be really interesting if you got really into it and like learn all the strategy and history and whatnot. Could be up my alley if I had the time. If I didn't already have a bajillion other things to be into. Anyway, yeah, it's 2 a.m. Well, it's 1:42, but yeah. How's about I disappoint everyone? I mean, we're getting somewhere. We're looking at stack stuff. We're seeing, interestingly, that all of a sudden it's still failing inside of the init occasionally. Let's look again. I bet you money this is going to be F7 still. Oh. 1B. Tell me what you can see. Look at that, F7. 01, F8. Yeah, see, like, it looks like when it warms up, it manages to get past that first one, but then isn't quite ready for the next one. So that is interesting. I should maybe, realistically, when I get back to this tomorrow, like, this is sending the sense interrupt command. Instead of failing the whole thing, I might want to just retry that, or just increase the delays some more, because it looks like it's marginal. When it gets warm, it looks like the timing improves when it's been spinning for a while and it's been on for a minute. Let's test this really quick and see if it... Oh, well, see? Like, now it started up toot sweet. So, O01B, tell me what you contain. Wow, it's F7. O1F8, UD-doot. That's great. Ooh, now that's fun. E238. So it even got a touch further. So, yeah, I think this thing is just warming up and getting slightly faster at executing the commands, or we're hitting them at just the right time that it gets a little further. But it still looks like it's just a marginal thing. And I might need to increase those timings even a little bit more. Maybe consider doing two nested loops there. Or, ooh, we could do like a wait for v blank. That's a thing that we can do, because we already know how to do those, and that's 1/60th of a second, which seems like a not terrible amount of time to wait. That could be a nice hack. Anyway, let's get to that next time. Dave Cooter says E245 will be the next PC -1 after the return from the function being called. So where did that JSR at E242 go? Yeah, I don't know. We'll find out tomorrow. Assuming after my workday I am conscious enough, because the time disappeared on me. Allian says, copy 2 of read-a-sector or bust _ I mean it _ final 2 - copy 3 _ final.mp4. I promise you, I'm making a promise right now. If it overflows after tomorrow, which it almost certainly will with the rate this is going, I will name the subsequent one exactly that. I will go back to chat. I will steal it. I will see if YouTube will let me put in a title that long, but and Hylian says, maybe you need to wait seconds instead of cycles. It shouldn't be as long as seconds, but it's just that cycles are so fast that I am potentially missing things that are slightly slow to come in, including things like sense IRQ, because as far as I know, sense IRQ is kind of waiting for the IRQ to happen before it returns. And Dave says, good night, all. Hollian says, good night, Dave. Hollian says, smile at the title theft. I will do it. This is a plan. All right, everyone who is still awake, thanks for hanging out. Go the fuck to bed. It's a Sunday. It's a Monday, East Coast. Which I know Dave is in, so Dave, go to sleep. Worm says, no worries, the GoTech will be faster. For these commands, they actually really shouldn't be too dependent on the floppy hardware. Yeah. But we do need to get that GoTech in there. Trey says, your stack was eaten by a group. Okay. Gotta go. You guys, I have a thing to tell you, and that is, see you, love you, bye.